Okay, for our final video here for this lesson on the exponential properties and radical properties in Module 4, where we'll look at exercise 5 and finish out the lesson here. So if x equals 50, y equals 12, and z equals 3, the following expressions are difficult to evaluate without using properties of radicals or exponents, or a calculator. Use the definition of rational exponents and properties of exponents to rewrite each expression in a form where it can be easily evaluated. Then use that exponential expression to find the value. Okay, so let's take care of this here. So looking at this right here, we should probably try and simplify, we should probably try and simplify this radical expression before we plug in our numbers up here. So what are we going to do? Again, we'll break up this so that we get the square root of 8 times the square root of x to the third times the square root of y squared. Okay? We'll then furthermore break down the square root of 8 to be square root of 4 times the square root of 2, allowing us to take the square root of that 4, 2, and then we have the root 2 left over. Okay, for the square root of x cubed, again, we'll break up that x cubed so that we create perfect squares. So we'll have one x squared we can pull out, and we'll be left with a square root of just x to the 1. Which will, square root of x squared will give us x, and then square root of x, like that. Finally, we have the square root of y squared, and that's just taking the square root of a perfect square, so we end up with just y. So, putting all these components together in a product, we get 2xy square root of 2x. Okay, the 2, the x, and the y go together on the outside here. The root 2 and the root x go together to make root 2x. Excuse me. So, this is our answer, and now we can plug in here if we want to get our answers. So we'll sub in our answers, our numbers here. We get 2 times 50 times 12, square root of 2 times 50. So 2 times 50 is 100. 100 times 12 is going to be 1,200. 2 times 50 there is going to be the square root of 100. And so we get 1,200 times 10 equals 12,000. Okay, continue looking here. Letter B, you're going to do cube root. So again, we'll break this up. Cube root of 54 times the cube root of y to the 7th times the cube root of z squared. Cube root of 54, we're looking for a perfect cube that divides 54. So, for example, what are perfect cubes? Well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on and so forth. For 54, that divides evenly by 27. So you can make it cube root of 27 times the cube root of 2. Okay? For the cube root of y to the 7th, we no longer want to make perfect squares like we did up here when we had square roots. We want perfect cubes from this. So we can make a y to the third, another y to the third, that's 6 now, right? And then we'll be left with a cube root of just y. Finally then, we have the cube root of z squared, which we can't do any further because there's not even one perfect cube we could pull out. Okay, so the cube root of 27 will simplify to just 3. Cube root of 2 stays that way because we can't simplify that. These will just simplify to y. And then you get cube root of y. And this is the cube root of z squared. So combining all of our terms, we get 3y squared cube root 2yz squared. Again, combining all the numbers that are outside the radicals and all the numbers that are inside the radicals to create this. And now we can plug in our numbers, 50, 12, and 3, So there's no x, so 12 goes in for y. Um, 12 goes in for y, and then 3 in for z. Okay, 12 squared is 144, and then 3 times 12 squared is 432. Cube root, 2 times 12 is 24. 24 times 9, 216. Okay, the cube root of 216 is 6. So this is 432 times 6, or 2,592. Okay. Again, if you want to check your cube roots, always feel free to just continue this list here. So this would be 64. This is 125, and 6 cubed is 216. And again, you can just keep going. Okay. Order these numbers from smallest to largest. Explain your reasoning. Why don't you guys go ahead and do that? Okay. Order the numbers from smallest to largest and explain your reasoning. So look at them and think about how you could determine, the order, the power of these numbers, or the value of these numbers, and which one's biggest and which one's least. Okay, hopefully you had a chance to do that here. So some things to help us compare. I see that 16 and 32, for example, are both powers of 2. So I could rewrite 16 as 2 to the 4th to the 2.5 power, which is then a power to a power, so we can multiply those two. And 4 times 2.5 is going to be 10. So this is 2 to the 10th. Okay, and then 32 as well can be written as a power of 2. 32 is 2 to the 5th to the 1.2. And again, we have a power to a power situation, so we can multiply. And we get 2 to the, excuse me, 2 to the 6th. Okay, and then 9 to the 3.1 though, well, that's a little bit trickier because 9 to the 3.1 is not a power of 2. But we can rewrite 9 as a power of 3. It's 3 squared to the 3.1, which will give us 3 to the 6.2. And so it's clear here which one is the small, well, sorry. We can at least compare these two relatively simply. Which one is the smaller one, which one is the bigger one? 2 to the 6th is definitely less than 2 to the 10th. But where does that 3 to the 6.2 go? Does it go in here between the two? Or does it go here at the smallest number? Or does it go here as the biggest value? Which one is it? Okay. Well, let's see here. So 2 to the 10th, without actually typing this into our calculator, it's going to be a little bit tricky, I think. So let's see here. So 2 to the 10th is going to be 1,024. Okay. 3 to the 6.2. Well, let's just do 3 to the 6. So 3 to the 6 is 3 times 3 times 3 times 3 times 3 times 3, which is 9 times 9 times 9, which is 81 times 9, which is 729. Okay. And 6.2 is a little bit more than that. 2 to the 6th is 64. Okay, so 6.2 is going to be a little bit more than the 729, but I don't think it's going to be quite big enough to be the 1024, so I feel like the order will be this. 2 to the 6th, and then 3 to the 6.2, and then there's your order in least to greatest. Okay, so lesson summary. There again, you can see all those different properties we've seen. Thanks for sticking with me, guys, and we'll see you in Module 5.